this is the final, not the final one. It's actually just like if before the final lesson, this is the last one before the final one. So tomorrow we're going to cover your assignments and also applications of differentiation. But today's class, we're going to look at differentiation. I mean, your tutor, Timmy. So I've already sent my email to the group chat. You can ask any question about your assignment. I'm willing to ask you what to help you about it. So let's go to today. We'll look at differentiation. So today you learn about what differentiation is, what differentiation is. You will see how to apply it to solve graph-based problems. So, and also what it is also what a single. So it is one of the single most important topics, in maths. You have to, let's look at that. So you need to be able to find the gradient of a function of a formula. So on the straight line, I taught you this thing before. Finding gradients on a straight line is extremely very easy. It's just for you to find you pick two coordinates. I told you earlier in the previous discussion, you pick two coordinates. You find the difference in y-axis, divide by the difference in x-axis. You now divide it by each other. So on the curved graph too, the gradient is always what? Changing. On the curved graph, the gradient is always what? It's always changing. So, and it's always actually what? It's always changing. So if its value depends on where you are along the x-axis. For example, you can see that this is a curve now. Use a curve now. You can see that the gradient here is going to be different from the gradient here. So the different gradients can be shown by tangents, and these lines that touch the curve is only what? One place. So differentiation is a process where we can find a formula to give the gradient on the curve at any point. So we're going to be more practical now about it. So if the general formula for differentiation is this. So if you say that y equals to ax to the power of n, the formula is this. If you say dy dx equals to, you bring this one down, n a x, then n minus 1. So let me give you an example. If you have 3x cubed, can you see? You will assume, no, let me just put to the power of 4 there so that there will be no clash of numbers. So can you see that a is the 3, x is x, and n is the 4. So you bring the n here. So that gives you what? It's going to be what? 4 times 3, x to the power of 4 minus 1. And you see, that gives you what? 12x cubed. That's it. That's the answer. 12x. What cube. So the same thing applicable to this one too. When you see x cube here, so you have to differentiate it. You bring, there's still, when you don't see a number beside the x, you assume that number is 1. So you bring this one here. That gives you what? 3 times 1. Then you take away 1 here. So that gives you 3x squared. So now, Yusuf, I'm going to ask you to do one. Look at this one too. You can see the examples are there. So if you have something like a 4x to the power of minus 5, so you're asked to differentiate something like this. The same formula to the same application. So you move this one to this place. Then you now take away 1 from it. So that gives you minus 5 times 4x to the power of minus 5 minus 1. That gives you minus 20x to the power of minus 6. Hello. So I'm going to ask you to do a question before we move on. So do 2 questions, sorry. I'm going to pause it now. Y equals to 5x cubed and y equals to minus 3 X for do those questions. Why I pause. So if you did it, it's put that one there. I go what the Y, the X is equal to 15x squared. And you see, you bring this one here. It's go to what 3 times 5 is 15, then minus 1. This one, you put that one to be what? Minus 3 times 4, x to the power of 3. Let's go with minus 12 x cubed. So that's actually how to do that bit. So sometimes too, the functions might not be straightforward. The functions could be in the reciprocal functions. So for example, now if you are given like y equals to 1 over x, so sometimes it's a bit tricky for you guys to work out this. So this one can become what? It's going to be what? Y. It's going to be y equals to x to the power of minus 1. So if you have something like this, y equals to 1 over x squared, that's going to be the same thing as what? Y equals to x to the power of minus 2. Can you see? So it's going to be easier for you to do than for you to look at in that fractional form. So if you have something like this, y equals to 2 over x cubed, that gives you like y equals to 2 x to the power of minus 3. So if they ask to differentiate y equals to 1 over x to the power of 4, this might be tricky, but just write it differently. It's going to be what? Y equals to 1 over x to the power of, it's going to be what? Y equals to x to the power of minus 4. Now differentiate this one. That gives you minus 4 x minus 4 minus 1. So that gives you minus 4 x to the power of minus 5. So if we have something like this, y equals to 6 x to the power of 4. That gives you y equals to 6 x to the power of minus 4. So it's going to be what? So that gives you what? Minus 4 times 6 x to the power of what? Minus 5. That gives you minus 24 x to the power of minus 5. That is. So you just need to be able to know how to figure out those ones out directly without this thing. So it could also be square too. It could also be like square. So if you have something like this, like y equals to so that's square root of x. So in indices, square root means what? X, it means what? To the power of half. So if they say square root of x, it means that what? X to the power of half. So in this case, it's going to be what? Y equals to x to the power of half. So now the y dx, the y dx, you can just put this one again. It's going to put 1 over 2 times x, 1 over 2 minus 1. You see, that gives you 1 over 2x minus 1 over 2. That's the answer. So you can actually see that one. That's actually what that is the answer. So if you have something like this too, y equals to cube roots of x. So cube root means what? X to the power of what? Of half. 1 over 3, sorry. So that gives you equals to what? X to the power 1 over 3. Then that gives you what? 1 over 3x. So 1 over 3x, then the other one, just do 1 over 3, minus 1. That's going to be what? Minus 2 over 3. So it could also be a fraction and a root. So if it's a fraction and a root, so it's a y equals to so that gives you 2. If we could say that 1 over root 2, sorry, root x. So that gives you 1 over x to the power of half. That gives you x to the power of minus 1 over 2. So now you differentiate it, that gives you minus 1. Same approach to times x to the power of minus 1 over 2 minus 1. That gives you 1 over 2 minus 1 over 2x minus 3 over 2. That's it. So this thing. So I would like you to look at, we want to look at maximum. So 1 second, just put that one out. So another one is also what, we use the final part we're going to look at. We want to look at how to find the maximum at the minimum point, in this in differentiation. So look at this one and say that so let's calculate the gradient of what is the curve. So if you have to find the gradient of this curve, you say that when is this? When I say f of x equals to x squared, where x equals to 3. So if you want to do that, you have to differentiate first. When you differentiate, you now substitute what? The value of x in there. So let's differentiate first. So y will be equal to x squared. Then the y, the x will be equal to what? 2x. So because we said x equals to 3 there, so it's good what? 3 times 2, 6. So calculate the gradient of the curve at coordinate this. Gradient of the curve as what coordinate that. So that one just require you to put that one coordinate curve at curve this at coordinate that. Differentiate to get 2x. Then substitute the value of 2 there. And you see you got -4 there. That's it. That's the gradient. That's got what? That's -7. That's -4. So just so that is what she said. Where we can find the coordinate of the stationary point on a curve when this is 0. So for example, let's find the coordinate of the stationary point when the equation is this. So the first thing that I have to differentiate, if you differentiate 3x, x cubed is going to be what? 3x squared minus 12, and one is going to be 0. Then we must be equal to 0. So you go to 0, now solve for x. So that gives you what? X squared minus 4 equals to 0. So you now factorize it. X minus 4, x plus 4 equals to 0. So x equals to 4, or 2 is 2, sorry. X equals to 2, or x equals to what? -2. So you've already got the coordinate for x now. So now, you now go and find the coordinate for y. Since you know that x is what? X is 2 or -2. Just go and put it there. So x equals to 2. X equals to -2. So you can see that you see when you put 2 there into that original equation, you got what? -9. And when you put -2 to the original equation I shown on the screen, you got what? 23. So the coordinate is going to be 2 minus 9 minus 2, 23. These are the what? These are the stationary what points. These are the stationary points. So stationary point, I will call the turning point. So that's actually what you need to do on that. So that is deciding the nature of what, or the stationary point. So using this method for for the other stationary points, this. So let's check the value of x. The value of x for this one is, you can see those values of x. So if you do this one, the value of the y, the x, you put -2 there, you're going to get this. -2 there, you're going to get 0. If you put -2, but now you're going to get 0 into this equation. Then this one too, you get what? -1.7. So this one is what? Increasing. This thing is so the maximum. So the maximum turning point is going to be what? -2, and what 23. But this is actually what's shown on the screen for you. So this is just the most important thing. Differentiate it first. When you differentiate, the values you get for x, substitute those values into the original equation, then you'll be able to know the answers there. So now let's go check minimum and maximum quickly. So just going to look at example, then we wrap it up. So examine this exam type questions. So find the coordinate of stationary point, examine the nature of it. So stationary point, like I told you, either differentiate, find differentiate it, second differential. So you differentiate it equals to 0, 3x squared minus this equals to 0. You find out what the value of x is. And you see, we got that. So when x is minus 1, you got a. When x is minus 1, you actually got 8 there. So there we have what? This is what is the maximum. Just need to actually be able to. So when x goes to 5, you put that one there too. That's where you actually get minimum. So how would you know on your graph? So can you see the point here? The one that goes here like this, that's the maximum. The one down here is the minimum. So you determine based on where they are in the y coordinates. So can you see that the y coordinate, this one is what? Minus 100 is further down. That's going to be the minimum. And that one is going to be what? It's higher up than minus 100. That's going to be the maximum. So, it's just straightforward. I expect you to just give 1 or 2 examples in your assignment, and let's see how you actually understand it. It's not what should give you a lot of problem if you follow these slides and actually answer the questions actually what they have to answer the assignment there. So Yusuf, now, can you unmute yourself